Hi, so I'm performing the iodine clock reaction at home. I've gathered all the necessary materials: peroxide, cornstarch, I have iodine, and the vitamin C tablets. And I've already pre-mixed a couple of the mixtures just because I've already tried to do this experiment once and it ended up being a little bit long with the distilled water, like having to measure it all out. And then it was just a lot of steps. So in here I have the hydrogen peroxide. In here this is the cornstarch and water mix, which I still need to microwave, and I will do. And then in here we have the vitamin C crushed up tablets along with water. I just put the mixture in the microwave, so it is heating up until it's boiling, and then I have my iodine in here. Yeah. All right, now I've come back and the mixture is heated up. There's steam coming off of it, and I'm going to actually re-pour it into this just because it's a bigger container, so it'll fit the hydrogen peroxide as well. So I'm just going to pour that over right now. It's very hot. That is so warm. Okay. And then I'm going to take the 150 milliliters of hydrogen peroxide and pour it into the cornstarch and distilled water mixture. I'm glad that I changed the plate thing that I was in because it definitely would not have fit in the first one. So now we have this mixture. Okay, so I've been stirring this mixture just so we can be finished with solution B and set that aside. So after stirring, this is what it looks like now. And solution B is done with for the moment. So I'm going to set that aside. And then I still have the vitamin C and distilled water solution. So now we need to add iodine to it. So I'm just going to add that in, and I know that the whole point of it is that it is darkly colored, and so it's supposed to go back to the original color even though the iodine is very dark. And so I think it looks a little bit darker on the camera than it actually is. Okay. Yeah, so I really don't think you can tell on the camera very well just because of the lighting, but it is coming back to the earlier shade that it kind of looked like. So I think there is enough vitamin C in there. I think there is enough of that presence in order for it to kind of revert back to the similar color despite how dark iodine is, which even shocked me. So now that this is talking about the presence, that this is created because of the presence of iodine, now it's created iodide, which is what the video explains. And so I am going to now go add it to top it off to around 500 milliliters with distilled water. So I will be right back, and then we will have finished off solution A. All right, I had to mix it and move it from a lot of different containers just because I don't have a ton of things that fit this much liquid. So now we have this, and it is so it looks like it's tinted just because it's like a not clear glass. So that is solution A. All right, so now this should be the fun part with the color change, but now I'm going to add the same amount of solution A as solution B to this beaker. So took that from here, and then I will do the same with solution B. Just have to make sure I'm looking at the right measurements. Seems about right. I'm going to add that to solution B. And then we are going to mix and hopefully wait for the color change. So now after some stirring, we see that the color has changed, which is cool. It definitely took a while. I think a little bit longer than it seemed like in the video. But that was very interesting. So, yeah, I really liked this experiment overall. I thought that it was a little bit difficult to find all the ingredients just because for some reason my grocery store was out of a couple of them. But either way, I thought it was like a really cool experiment to see. And I thought the color change was very interesting to observe. Now I'm kind of going to go into and explain a little bit more why that color change did occur, and then we can be done with this video. So I believe initially to start off, kind of like the equations of the solution A and solution B separately is like hydrogen peroxide reacting with iodide to form triiodide with water, and then the other one is triiodide reacting with vitamin C, which I believe is ascorbic acid. Sorry, it's hard for me to pronounce that. Which is forming iodide and dehydroascorbic acid. So I believe the purpose of this was to measure the rate at which reactions kind of take place, how long it takes. And since there's like a variable amount of time that this experiment takes, and that is like due to various different factors, like even in the video they explained that temperature affects it, so heating up the solution can help it just react quicker. Mixing it, how like quickly they're going into each other, that also affects how quickly the color solution or how quickly the reaction takes place. More of I believe it was solution B into the beaker would also help quicken this. So there's just in general a lot of factors in which this reaction can have in order to make it go faster and like make the color change a little bit quicker. And so the color change basically is occurring when I believe it's the iodide reacting with starch to form like that complex together. And so, I mean, I didn't really measure how long it took me on a watch, unfortunately, but it definitely did take like a few minutes in order to get that dark blue color. Happened pretty quickly, so it was really important to just kind of like observe and make sure that you were keeping an eye on your solution, because I did step aside a couple of times and luckily it hadn't changed yet. But I think the stirring definitely did help, because I noticed that after I came back and was continuing to stir it uniformly, that it was kind of like a much quicker change. And so I was looking into it a little bit more just to kind of understand the reasoning why the solution was turning blue, kind of like the main reason behind it, and looking into it, not just using the video, but also other resources as well. I found that amylose is the compound that is kind of responsible for that like specific color, that hue, which the colors are basically produced or like caused by charge transfer complexes. And so that amylose that I was talking about just a bit ago is kind of acting as that donor and the polyiodide as an acceptor. And so this complex is kind of absorbing light of a different wavelength than polyiodide typically. And so then that color is changing to dark blue, which is what we see in our experiment with the final solution that you get. And so just learning about that color change a little bit more and just kind of like the reasoning behind it, I thought it was really interesting just because I didn't have a lot of prior knowledge on it before, and I've never done this experiment except for maybe like many years ago in like high school. So and I think it's a different version. So it was really cool getting to kind of do it myself. And obviously it came with its own errors of like human errors, like measurements, just kind of like making sure you were using like direct measurements as well, not like eyeing the measurements of like all the liquids, and making sure that the pills were crushed up enough, like the filtration was working right, so you didn't have like chalky liquid. And yeah, in general, I thought it was a very interesting experiment. There's definitely a little bit more work put into it than I expected, but overall, very rewarding, and it was good to know why that color change happened. So, very interesting overall. Thank you.